All right, well, thank you. And I appreciate anyone who's online today to listen to me. I know you're busy and glad that you're tuning in, and hopefully you'll enjoy my presentation. But I want to recognize my co-authors, grad student Chad Abbott, and then my colleagues, Tommy Butts from the University of Arkansas, my friend and mentor, James Gricker from Texas A&M, and Mike Marshall from Clemson. Let's see if I can. All right, just to get everybody on the same page, if you're not familiar with Liberty or the common name of glufosinate, it's a herbicide that was first discovered around 1981 and was commercialized for use around 1993. It's in a phosphenic acid family. It's a glutamine synthetase inhibitor, which is considered a WSSA group 10 herbicide. It's primarily used for pre-plant burn down weed control and for post-emergence weed control in tolerant crops. There are many formulations that are available. There's Liberty is the brand name. There's numerous generic formulations in the marketplace right now. So why would I be interested, or would we be interested in pre-plant Liberty or glufosinate applications for peanut? First of all, glufosinate or Liberty in Georgia is used extensively in cotton, so it's around the farm and growers are very familiar with it. It could be very helpful for the control of horseweed, annual morning glories, and pigweed prior to planting. Liberty is or glufosinate is also very effective on peanuts. So in fields that need to be replanted because of stand issues, the Liberty could be used to terminate the existing poor stand. Always when we have a label, I'm always interested in getting labels to help prevent any off-label use. And currently it's not labeled. We have a 180-day label restriction for peanuts. So if you read the label, we really don't have any room to use it legally. With that said, our goal of this research was to evaluate peanut response to soil plot applications of Liberty or glufosinate. And just to make it easier, I'm going to continue to say Liberty so I don't have to keep repeating myself. There were 4 locations that were conducted in 2020. One was in Blackville, South Carolina. I was in Tifton, Georgia, or Ty, Georgia, Newport, Arkansas, and Yoakum, Texas. Generally, traditional small plot techniques were used. Treatments were replicated 3 to 4 times. The design was a randomized complete block design with timing and rates as the factors. The trials were kept weed free. We took various kinds of data, density, plant heights, widths, yields, depending on the location. And then all data was subjected to analysis and variance using for Fisher's protected LSD. And there were no interactions between timing and rate, so I would just be presenting data by the main factors. Just a quick look at the cultivars, planting dates, application dates for the various locations. Of course, everybody's going to be growing the varieties that are popular there in their areas. Just one note, and I don't know why this happened, because it was my idea for the test at this location. I modified it a little bit based on some questions that I had been getting at the time. Everybody else had 1 day before planting, and I winded up doing a 7-day before planting plus 1 day after planting treatment, in addition to the 1 day after planting. So slight modification there at the Georgia location. The soil types for the locations are listed here. It's interesting to note that in Arkansas, look at the difference in their soil type compared to some of these other areas. We grow peanuts much more clay and silt than we have certainly in South Georgia. I wonder how they're digging them. All the treatments were applied with backpack sprayers. Again, everybody's using whatever they typically use in their systems. Generally 15 to 20 gallons per acre is common for weed science research, and however fast everybody walks, that's the speed at which they're applied. So let's get into the results, if I might. Let me get rid of that mouse here. Before I go any further, let me set up my slide format for you, because it's going to be the same for all the slides as we go through the rest of the presentation. Since there was no interaction between rate and timing on each slide, I'm going to have the timing effects on the left and the rate effects on the right in every slide. And this is just the effects on peanut density in Georgia. You'll notice that timing had no effect. We have a P of value of 0.53. We did see a significant rate effect where we did get a slight reduction in stand when the 64-ounce rate was applied. And I'll mention something about that in a minute. That's in Georgia. In South Carolina, we did see a timing effect. We saw a slight reduction in stand with the 1 day after planting timing, but no rate effect at that location. Just to show you a couple of pictures, this is from the Georgia location, what the plots look like. This is on 30 days after planting. The slide on the left is the no Liberty, and then the slide on the right is where we made 2 applications of Liberty, one at 7 days before planting plus 1 day after planting. You'll notice in the left that we did not have a great stand. We had some seed quality issues in 2020, had a significant amount of splits. So our plant population was a little lower than desirable. But I think as you see, as we progress, the plots that the next few series of pictures I'm going to show you are all the same plot just over time. So this was at 30 days after planting. This was at 55 days after planting. So here you see the peanuts were able to fill in nicely, and really no difference there. Observational differences between the untreated and the treated. Here's at 86 days after planting. And then here's at 118 days after planting, right prior to digging of the peanuts. So really no visual symptomology or causes for concern in that scenario, which would be the worst case scenario, or the most rate that we might actually apply or could get applied by accident. Now let's just jump into yield. That's probably more important than anything. We'll just go by state. This is Arkansas. If you look at time of application, there's no effect. P-value of 0.3. If you look at rate effect, there's no rate effect there. P-value of 0.26. If we look at Georgia, again, no time of application effect. Our P-value is 0.56. And then no rate effect, even though we did see a slight reduction in stand at the 64-ounce rate, a P-value of 0.23. In South Carolina, no timing effect. But interestingly, and sometimes this happens in research, we see things that sort of don't make sense. The untreated yielded less than the treated, and these were weed-free plots. So I don't know how to explain that, but that's the way the data fell out. And then here's Texas. Again, in Texas, no rate effect or time effect. Yields were a little bit lower there. They had some weather conditions that caused them to have lower than optimum yields in that particular scenario. So in summary, I would say generally peanut tolerance to Liberty was very acceptable. There were no interactions between rate and time. As far as peanut stand goes, in Georgia, we saw a 6% reduction by the 64-ounce rate. And in South Carolina, we saw a timing effect where the stand was reduced by 3% by the 1 day after planting. There were no negative effects of timing or rate on peanut yield. And in South Carolina, we had that a little anomaly where the 32 ounces and the 64 ounces was actually better than the non-treated check. Kind of dropped the ball in BASF stand now. They currently have the registration for Liberty. We've approached them about getting a label, giving them the data and information we have regarding potential acres used. I don't know if it's going to go any further than this presentation. Again, I would love to have it for the reasons that I stated, but we may not get it in the end because there's not enough acres to support some of the work that might need to be done to get the registration. If you're interested in this slide set, it's currently on our UGA Weed Science webpage at www.gaweed.com. You're welcome to take a look and use it. You use the data or information any way you want. With that, David, I will stop sharing my screen. Maybe I went a little fast, but maybe we're getting close to sort of being back on time. So I'm the only person in this section. So if anybody has any questions, I'd be glad to try to answer them.
Sure. Thanks. Thanks, Eric. There's 88 people watching you today.
Thank you.
For sure. Well,
or at least their computers
roughly 88.
The computers were on. They may not have been there.
Well, we're going to say they're on.
I will.
Yeah. So, thanks for the presentation, Eric. We've got time for a question or two if there's Anybody has one? And I had a question, Eric, if the, and you might have said it initially, did everybody look at for their 1 day before and 1 day after? Was it looked at in a no-till situation, or was it in conventional
I
till?
think
And
it was
just
all conventional tillage, David. So it was,
okay,
so all those applications would have been made to bare soil.
okay, cool. And I
Which-
didn't know, like, for example, if it had been in a conservation tillage and you sprayed it right after, there'd be a little bit more room for some spray to get down closer to the seed, just because sometime in no-till
Right.
there could be. Mhm.
Yeah. So good point. Something, again, if BASF decides they're interested, there needs to be a little bit more work done before we get the final label. That could be something to look at. What happens if, say, in your scenario, you're suggesting, what if the furrow is open perhaps, and we get some liberty down in on that seed? What's going to happen?
Okay. Thanks. Let me check the toolbar so I don't see any other questions. So I think we're in good shape. What's your biggest challenge with small plot research?
I'm getting old.
Okay. Just to follow up on your question for Bill while ago.
My mind is young, but my body is old.
Well, you still got your hair, so things are looking great. So thanks a lot for coming today, Eric, and providing that good information for us.
Appreciate all you do, David. Thank you.
Thank you.